Hi class, today we are going to be solving real application problems for trig using right triangles. Okay class, today we are going to be doing right triangle applications. So we're going to be solving some real life problems that involve trigonometry with right triangles. So the first problem involves a point 100 feet from a public library. So we have this building here, this white rectangle, and we're going to be 100 point away. So we're going to be 100 feet away right here. Is from the public library, and the angles of elevation to the base of the flagpole. So here's the flagpole on top of the library. And the angle of elevations are 28 degrees, so the smaller one is 28 degrees. And then the larger angle is 39 degrees, 45 minutes. The flagpole is mounted on the front of the library's roof. Label all the unknown defined variables parts of the diagram, and we're going to find the height of the pole. So we ultimately want to find this height here, which we're going to call h for the height of the pole, but our other unknown is how tall is the library, which we're going to call x. So we have two triangles that I'm going to pull out of here. The first triangle I have is the one that has the library side. So it has this x here, and then the base is 100. The angle is 28 degrees, and I don't know the hypotenuse, but I don't need to know it. The second triangle is the one that has the 100 as the base, that's opening up to be the 39 degrees, 45 minutes. And it has this height of x plus h for its total height, because the height is just the flagpole, and then x is just the height of the library. So my second triangle has an angle of, or this angle is 39 degrees, 45 minutes. My base is 100, and my side here is x plus h. So I can write two equations, and I can solve them for my two unknowns being x and h. So since I have an angle and its opposite side and its adjacent side, I'm going to use tangent. So tangent of 28 degrees is opposite over adjacent. And I can solve for x. So x, if I multiply 100 to the other side, is 100 tangent 28 degrees. Now the second equation I can get from my second triangle here. And I also have its opposite and its adjacent side. So I know tangent of 39 degrees, 45 minutes, is opposite, x plus h, over adjacent, which is 100. So I can solve for x in this equation as well. I can multiply both sides by 100, and I have 100 tangent 39 degrees, 45 minutes, is x plus h. And I can subtract h to the other side, and I have 100 tangent 39 degrees, 45 minutes, minus h equals x. Now I have two expressions that equal x. So those both equal x, so they can equal each other. So I know that 100 tangent 28 degrees is 100 tangent 39 degrees, 45 minutes, minus h. And I ultimately want to solve for h, which is the height. So I can add h to the other side. So I can add h over here, and then I can take this term and subtract it over to there. So h is 100 tangent 39 degrees, 45 minutes, minus 100 tangent 28 degrees. Now all of this I can plug into my calculator in degree mode. And I know it's degree mode because I'm plugging in degrees. And I get that my height is approximately, so h is about equal to 29.998, or h is about 30 feet. So to answer the question in a full sentence, I'd say the height of the flagpole is about 30 feet. And all word problems should have sentence answers. Okay, let's go ahead and move on to the next problem. Okay, this problem involves an airplane, which is 100 feet high. So here's the ground, and here's my lovely airplane, which is going to be flying in this direction. It's 100 feet high, so I have 100 feet. And it is 1,600 ground feet from its landing runway. So let's just say that this is the runway here, and it's 1,600 ground feet. So this distance along the ground is 1,600 feet to the runway. And the plane descends in a straight line to the runway. So at this point, if the plane were to go downward in a straight line towards the runway, determine the plane's angle of descent. So if the plane is going straight in this level, the angle of descent is the line parallel to the ground up in the sky down towards the path. I'm going to label with a star. It's my angle of descent. So the plane, it says, is going to descend in a straight line to the runway. So the plane is going to travel along this path right now. So it had been traveling parallel to the ground. So its angle of descent is this angle down here where it changes its path towards where it's going. So I want to find that angle of descent. So I have this angle here, which is the angle of descent which we want to find. But I'm going to use this angle theta inside this right triangle here. And I know it's a right triangle because we talked about the height. And theta and star are complements. They sum to be 90 degrees because it makes this 90-degree angle here. So I'm going to first find theta and use that to find star, our angle of descent. So because I have my angle theta and it's opposite and adjacent, I'm going to write a tangent equation. So I know that tangent of theta is 1,600 over 100. So I can use this to find my theta, and I can also simplify that this just becomes 16. So tangent of theta is 16. Now in degree mode, I can type in theta is tangent inverse of 16, and I can get my angle of 86.4 some degrees. Now remember, this is my theta, and I wanted to find my star. And I know that star plus theta, since they're complementary, they add to be 90 degrees. So I know my star, which is my angle of descent, is going to equal 90 degrees minus this number I have in my calculator, the 86.4 degrees, or my angle of descent is 3.6 degrees. And there you have it. Let's go on to the next problem. Okay, so let's talk about some directional bearings. So when you're on your land and sea, so if you're flying a plane or driving a car, when you're talking about bearings, most of the time we're talking about bearings in the sea or in the air. And the bearings are marked in two different ways. So for a sea bearing, land and sea, it's always going to be an acute angle that it makes with the north and south line. So for example, if you were traveling along this path here, the bearing that, or the angle at which you're traveling, since it's between north and east, the angle we're looking at is this angle between the north-south line here and the angle we're traveling. So it'd be north 78 east. So here's north, here's east, and there's 78 degrees. And it's always the angle between the north-south line and the direction you're traveling. So for example, if you're traveling along this path and you're going that way, southeast, the bearing has to do with from the north-south line towards the angle you're going, which in this case is 41. So we'd say south 41 degrees east. The last example I have here is if you're traveling along this path here. If you're traveling along that path, it's between north and west. So you measure the angle from north towards the direction you're going, and that angle is 71 degrees. So we'd say north 71 degrees west. It's always the north-south, then the angle, and then the east or the west. On air, the measure is always clockwise from north. So for example, if this is my north-south line and you're traveling this direction, your bearing is going to be whatever that angle measure is. So between 270 and 360 degrees. If you are traveling this direction along that path, your bearing is going to be this angle measure, however much that is. A bearing, in both cases, is the angle. Okay, let's do an example problem. In this problem, we have a plane flying at 500 miles an hour at a bearing of north 48 degrees east. So I know it's between north and east, so I know that this is north and this is east. So the angle, which is the bearing, is between north towards the direction I'm going, which is 48 degrees. And it's always starting from the north towards where you're going. So after flying 1.5 hours, how far north and how far east has the plane traveled from its original departure point? Draw a diagram and label all givens and unknowns. So looking at this 48-degree angle, we can draw a triangle here, a right triangle. And I'm just going to pull it out and make it a bit larger here. So I have this right angle. This is my 48 degrees, and this is my path that the plane is going. So the plane is moving this direction along the path. And I want to know the plane is flying 500 miles per hour. So this is 500 miles per hour. And it's going to go for 1.5 hours. So we can figure out the distance or the length that it flew in that 1.5 hours using dimensional analysis. So if we do 500 times 1.5, we're going to get out 750 miles. So if I label this as 750 miles, and I want to figure out if I started here, flew along this path, and ended here after 1.5, I want to figure out how far north and how far east the plane has traveled. So essentially, if I want to find how far north, I'm going to look for this side, which I've labeled N, and how far east it's traveled, I want to look for this side, which I found as E. So we have the hypotenuse, and I want to find its opposite and its adjacent side. So I can use sine, using opposite and hypotenuse, and cosine to find adjacent over hypotenuse. So let's go ahead and write those two equations. Okay, I went ahead and wrote cosine of 48 degrees is adjacent over hypotenuse, and sine of 48 degrees is opposite over hypotenuse. So ultimately I want to find n, how far north, and e, how far east I went. So I'm going to multiply my cosine equation by 750 and get the north value is 750 cosine of 48 degrees, and then do the same thing with the second equation and get the east value is 750 sine of 48 degrees. Now since both of these are in degrees, I need to make sure I'm in degree mode, and when I type it into my calculator, how far north is about 501.85 miles, and how far east is about 557.36 miles. And again, we should go ahead and write this in a sentence. So my sentence is, the plane traveled about 502 miles and about 557 miles east of the point of departure in the 1.5 miles that we traveled. Okay, thank you and have a good night.